Today we are going to learn about mastering Keras custom layer development. You'll gain the skills to design and implement custom layers using Keras for enhanced model flexibility and performance. Welcome to our session on mastering Keras custom layer development. In today's video, we will explore the importance of creating custom layers in Keras to enhance the flexibility and performance of your deep learning models. We'll cover the basic structure of a custom layer, delve into the implementation details, and provide examples of practical applications. By the end of this video, you will have the skills to design and implement your custom layers, enabling you to tailor models to specific tasks or datasets effectively.
Keras is a powerful framework for building deep learning models, offering a variety of predefined layers for common tasks. However, these standard layers sometimes fall short, particularly when dealing with complex or highly specific tasks. For instance, when working with unique data transformations or custom operations that are not covered by existing layers, you might find the need for greater flexibility. In such cases, creating custom layers becomes essential. Custom layers allow you to define your own operations and parameters, giving you the freedom to tailor the model architecture precisely to your requirements. Throughout this video, we will explore how to overcome these limitations by developing custom layers.
The need for custom layers often arises in scenarios where unique data processing or novel neural network architectures are involved. Custom layers provide the ability to implement complex behaviors and fine-tune performance beyond what is achievable with standard layers. For example, when working with a specialized dataset that requires a specific pattern of data handling, custom layers allow you to implement tailored transformations and operations directly within the model architecture. This flexibility not only enhances the model's performance but also expands the capabilities of Keras by allowing you to explore innovative approaches to deep learning tasks. By the end of this lesson, you'll be equipped to recognize when and how to implement custom layers in your projects.
Building a custom layer in Keras involves extending the base layer class and implementing specific methods to define its behavior. The first step is to define the class structure for your custom layer. This includes initializing the class by defining the _init_ method to set up any initial parameters. The custom layer also requires the implementation of key methods such as build and call, which define the layer's parameters and behavior during the forward pass, respectively. By leveraging the flexibility of the layer class as a base, you can create layers tailored to your specific model requirements. We'll discuss each component in detail, providing a comprehensive understanding of how to structure and implement your custom layer effectively. The call method is a critical component of any custom layer in Keras, as it defines the layer's operations during the forward pass. When implementing the call method, you'll focus on how the layer processes its inputs to produce outputs. This involves executing the custom operations that give your layer its unique functionality. For example, if your custom layer is designed to apply a specific transformation to the input data, the logic for that transformation would be included in the call method. It's also essential to handle inputs and outputs correctly, ensuring that the data flows seamlessly through the model. Once implemented, testing the call method is crucial to verify that the layer behaves as expected during the forward pass.
The build method in a custom layer is where you'll define the layer's parameters and ensure it is compatible with the rest of the model. This method is called when the layer is first used with an input shape, enabling you to initialize variables such as weights and biases. Understanding the input shapes and setting up the necessary parameters are crucial for the layer's functionality. Additionally, the build method ensures that the custom layer integrates smoothly with other Keras layers and models, maintaining the overall coherence of the architecture. Properly defining the build method is a fundamental step in creating a functional and effective custom layer that can be seamlessly integrated into your deep learning projects. Once you've developed your custom layer, the next step is to integrate it into an existing Keras model. Ensuring compatibility is vital, as the custom layer must work seamlessly with standard Keras layers to form a cohesive architecture. Deciding where to place the custom layer within the model is crucial, as it affects the model's overall functionality and performance. Combining custom layers with standard layers allows you to create innovative architectures that leverage the strengths of both. Testing the integrated model is critical to verify that the custom layer operates correctly within the model's context, offering the expected enhancements. By effectively integrating custom layers, you can unlock new possibilities and performance improvements in your deep learning projects.
Testing and debugging custom layers are crucial steps to ensure their reliability and performance within a model. Testing involves validating the layer's functionality, ensuring it produces the expected outputs given specific inputs. Debugging is essential to identify and resolve any issues that arise during the development process. Common issues might include incorrect data handling or unexpected behavior during the forward pass. Employing strategies such as unit testing and using frameworks like TensorFlow's testing utilities can help streamline this process. By thoroughly testing and debugging your custom layers, you can ensure they function reliably and deliver the desired enhancements to your model.
Custom layers can be applied to a wide range of real-world scenarios, offering creative solutions to complex challenges. For instance, they can be used to implement novel neural network architectures for image processing, natural language processing, or time series analysis. Real-world use cases include developing specialized layers for anomaly detection, image segmentation, or custom activation functions. Successful implementations demonstrate the versatility and power of custom layers, inspiring you to explore innovative applications in your projects. By examining these practical examples, you'll gain insights into how custom layers can be leveraged to solve specific problems and enhance model performance in diverse domains. In conclusion, mastering Keras Custom Layer development empowers you to create flexible and tailored deep learning models. We've covered the essentials, from understanding the need for custom layers to implementing and testing them effectively. As you continue your journey, I encourage you to experiment with creating and integrating custom layers in your projects, exploring their potential to solve unique problems. By developing a deep understanding of custom layers, you'll enhance your ability to innovate and optimize deep learning models, paving the way for advanced applications and successful implementations. Thank you for joining us, and we look forward to seeing what you'll create with these new skills.